No matter what you're creating, you should always try to capture the intent of the design as early as possible in the process. It's not uncommon for a design to change based on design problems or future revisions that you may have, so the ability to capture that design intent early on makes those changes much easier to deal with. Sometimes changes aren't even unforeseen, but planned in the life cycle of a product. In this sketch, you can see the simple formula used to calculate that the length is 1.25 times the width of this part. See that D2 equals D0, which is this dimension here, times 1.25. When you capture your design intent, you add intelligence to your design. The intelligence can exist in several different forms. It can be as simple as geometric constraint that forces two lines to be perpendicular or parallel. It can be a dimensional constraint that forces a dimension to remain consistent throughout a part. Or that dimensional constraint can be based on a formula, as in this drawing. Just as each part design is unique to the part, so is the design intent of each part. Capturing this intent is a process in which you must match your design intent with a feature or capability that makes it possible to create the design in the most efficient way. This allows for the maximum flexibility in making changes. Different examples of design intent are being captured at the earliest stage of the design in this object. This shows you that the circle is D0 minus 0.5 inch. A very simple design information added to this sketch makes this sketch very intelligent. If I was to come in here and change the size of this to 2.5, everything else updates correctly. When you're capturing design intent, it's always good to identify the geometric relationships first. For example, this being perpendicular from one line to the next. This line being tangent to the circle, whereas this line is tangent to this half of the circle. Then identify areas that are prone to change as a result of design problems. I know that this width is going to change, but this is always going to be 1.25 times. So I set up the dimension to be this is the driving force, this is the flexible force that's based on this dimension. Identify areas of symmetry. We can actually come in here and add in a rectangle, for example, and another rectangle. And then if I draw a line across this middle section here, I make sure that this line is fully constrained. When something is fully constrained, it changes color. It's important that when you're done with your sketch, that the entire sketch is fully constrained. Now, if I want to make these two rectangles symmetrical, and I want to make them the same size, come up and I select the symmetrical constraint. Select two lines. I select the center line to say this is where it's going to be symmetrical about. I don't have to select my center line again because it will remember it. I can just keep adding in constraints. And then as I add dimensions to these, say I make that 0.375 by 0.5, you can see that it's understanding what I'm doing. I missed one here, so I can go back and get it. I drag this down. See, it actually moves. Come up here and I can select dimension. Put a dimension on there. Make that dimension the same as this dimension. And now everything's locked down. I may even want to come in here and tell it that this line is a construction line. Not really part of my design, it's just there for being symmetrical. Let's try to create this on your own. What we're going to do is we're going to start a new sketch or new part from the standard IPT. Click 2D Sketch. We're going to click the line command. As you draw, you'll notice that Inventor gives you these little glyphs. The glyphs are these little markers that tell you what it's doing. If you're familiar with AutoCAD, it's very similar to the O-snaps. So I draw my first line. Notice I didn't add a dimension to it because that's not important yet. If you hover over the end of the line, you'll notice I get a little gray dot there. Pick with my left mouse button and hold, and it converts it from a line to an arc. I get the glyph there at the bottom that tells me that it's tangent. Come up and I see my dotted line. That tells me the two ends of my arc are now vertically aligned. I let off my mouse button and I pull to the left. You see I get my tangent. I also get a parallel there by my mouse button and a parallel at the bottom line telling me that those two lines are parallel. And then I get a dotted line telling me that the back end of this part are now evenly aligned. Pick my mouse button, come down until I get the green dot to close it. So now I have my basic design. Come up and I click circle. Center point of my arc there. Draw out a random circle. Let's add some constraints in here. I'm going to choose the horizontal constraint. This is what we call the point of origin. So I'm going to click on that. Hover over this line until I see that green dot. That green dot tells me that that's the midpoint or center of that line. So I've locked that in. Choose dimension. And you'll notice that I dimensioned this line and it's way too small. With Inventor 2013, it's now smart enough to scale up my entire design based on that first dimension. It's a very big time saver with 2013. So I select my top line, then I select my 2 dimension, and I say times 1.25. Select my back end and then my origin point again. Select my back dimension, say times 0.75. Then I select my circle. Say my circle is 2 dimension minus 0.5. What that does is it leaves me a 1/4 inch all the way around so that if my dimension here changes, my circle will always be a 1/2 inch around the outside. Right now my sketch is fully constrained. This is what I want. I like to see it black, meaning that everything is locked down the way it should be. I'll select line, hit the green dot, right click and hit OK to finish. I'm going to select this line, this little icon up here. I'm going to make it a construction line. Now I have my construction line or the center of my object. I'm going to draw 2 rectangles just at random. Doesn't matter what size they are. Hit escape. I'm going to come up and select the symmetrical constraint. Doesn't matter what 2 lines I pick, I just need to pick the 2 of the same on the rectangle. Once you pick that symmetrical line the first time, you don't have to pick it again. You can just pick 2 objects and it'll remember that until you either hit escape or you can right click and you can change where it's going to be symmetrical to by clicking restart. All my lines are going to be symmetrical around that one line, so I don't have to restart it. Add in my dimensions. 375. I'll make this about 0.5. Now I'm going to hit escape and I'm going to play with it a little bit. See how you can move it around? And it's like looking in a mirror. I'm going to finish this up by putting a dimension from here to here. 0.25. Dimension from here to here. I'm going to make it the same as that 1/4. Okay. Now if I come in here and change my dimension here, 2.5 instead of 2, everything stays where I intended it to stay. These rectangles are a 1/4 inch off the side. This has a 1/4 inch buffer around it. This is 1.25 times this, 0.75 times this dimension. I can even make these rectangles here a factor of this. If I come back in here and make this 2.0, I could say that this was this dimension divided by 4. Or make it a little bit smaller than that. Let's say divided by 8. which is a 1/4 inch. So now if I change this back to 2.5, instead of these being a 1/4 inch, they're 0.313. This goes out to 3. My circle, I wanted a 1/4 inch around it. These, I wanted 1/8 of this dimension. So they're intelligent. That intelligence is built into your sketch now. Remember, capture it early, capture it as simple as possible, and you want to capture the constraints before you capture the dimensions. Basically, what shape should it be before what size should it be? And if you notice, the very last thing we do is the size. AutoCAD users, this is the opposite of what you're used to, and this is very hard for you to get used to. But sketch it out very roughly. Doesn't need to be pretty. It doesn't need to be nearly the right size. Create the shape you want by using the dimensional constraints, perpendicular, parallel, tangent, symmetrical, and then add your dimensions and define the size of it. Very easy to capture design intent, and it's a very powerful tool. So try to make your parts as smart as you possibly can.